Picture this. A metal figure sprints down a test track, plants one foot, and whips into a spinning back kick that would make a martial artist flinch. No cables, no human puppeteer, just a biped machine balancing on one leg like it has been training for years. Now imagine realizing, as you watch the slow motion replay, that this is not a movie stunt. It is a production prototype that companies want to put in factories, warehouses, and eventually homes. This is the moment humanoid robots stopped being a joke reel and started feeling like a new labor force walking toward you. If you remember those old competition clips from the DARPA Robotics Challenge, your brain still holds the bloopers. Robots wobbling through doors, tripping over cinder blocks, face planting off stairs in front of a laughing crowd. Even Boston Dynamics' early Atlas looked like it was fighting the laws of physics instead of flowing with them. Fast forward to 2025, and suddenly you have Unitree G1 doing full kung fu sequences on slick floors, and Chinese startup Engine AI showing prototypes jogging, stopping on a dime, and spinning 180 degrees in a single stride. But here is the part nobody expected. This is not just a better puppet show. Under the hood, the entire brain and body of these machines has changed. Older humanoids moved like marionettes because engineers had to hand code almost every joint angle, every step, every turn. It was like animating a movie frame by frame. Today, the most shocking demos run on end-to-end neural controllers that map sensor data straight to motor torques hundreds of times per second. Instead of playing back canned motions, the robot is solving a physics problem on the fly, deciding how to move every joint in its hips, knees, ankles, arms, and torso together. Pattern break for a second and think about your own body. You do not consciously script each muscle when you walk across a messy room. You just move. That is what these controllers are starting to do for machines. How do they learn that kind of fluid motion? Not by trial and error in a lab where every fall costs thousands of dollars. They learn inside high-fidelity virtual worlds like NVIDIA Isaac Sim and Isaac Gym. Companies spin up thousands of digital clones of the same robot and let them crash, slip, and faceplant millions of times in simulation. The neural controller is rewarded for staying upright, rolling out of bad landings, and recovering from shoves until balance and agility become second nature. In a minute, you will see why this virtual training loop is the secret weapon behind that viral backflip and also behind something much more important than a cool kick. The trick that makes sim to real transfer work is called domain randomization. In the virtual world, engineers constantly change gravity, floor friction, lighting, even sensor delay, so the robot does not overfit to a perfect cartoon universe. When the same neural policy is uploaded into a physical robot, it is already used to surprises like scuffed concrete or a wobbly pallet. Teams even feed motion capture of dancers, martial artists, and athletes into these simulators. The controller is trained to match those human poses while still respecting real-world physics. That is how you end up with a Unitree G1 that moves like a stunt double instead of a stiff lab prototype. But motion alone does not make a worker. The real revolution is in the invisible software stack called Vision Language Action Models, or VLA. Figure calls its version Helix AI, and it behaves less like a script engine and more like a general-purpose brain. Cameras feed raw pixels, microphones feed audio, joint encoders report body position, and this single massive neural network digests all of it at once. Instead of one system to see, one to talk, and one to move, everything is fused. The model does not just predict the next word. It predicts the next action token, like shift weight left, rotate wrist 2 degrees, or increase grip force slightly. This changes who gets hired next, because it turns a robot into something that can follow plain language instructions on a messy factory floor. Take a simple instruction. Put that box on the shelf. First, a speech layer turns your words into text while the cameras scan the scene in 3D, segmenting boxes and mapping shelves. The VLA model grounds the phrase that box to a specific object with coordinates, size, and weight estimate, and on the shelf becomes a target region with height and clearance constraints. From there, the brain explodes the sentence into micro-intentions. Walk to the box, orient the torso, choose a grasp, lift while staying balanced, navigate around people, place without collision. None of this is hand-coded. It emerges from millions of episodes in sim and in the real world. And here is the twist. The same network that understood your words can instantly adapt if a human nudges the box or the shelf is cluttered. Older robots had brittle pipelines. A vision system guessed where things were, a planner drew a path, and a low-level controller tried to execute it, often failing when reality did not match the plan. With a unified vision language action model, there is no clumsy handoff. The same neural network that heard the instruction is also watching the scene and commanding the motors, updating its plan in tens of milliseconds. That tight loop between seeing, understanding, and acting is what turns humanoids from glorified CNC machines into embodied agents. Once you can tell a robot, help that worker pack orders, and it figures out the steps, backflips start to look like the boring part. In a moment, we will zoom out from the tech and look at the companies and the countries betting their industrial future on this. Meet the new mechanical titans. In Shenzhen, Engine AI wants humanoids to be as common as cash machines. Their latest demos show life-sized robots with eerily realistic faces, full body gestures, and smooth walking that feels more like a theme park performer than a factory arm on legs. Engine AI is not just selling hardware. They pitch a full stack of perception, large model planning, and cloud fleet management. They talk openly about robots guiding visitors in hospitals, patrolling campuses, and handling repetitive tasks in electronics plants. When you hear them mention tens of thousands of humanoids by the end of the decade, it sounds less like marketing and more like national industrial policy. Across the Pacific, Figure 03 is the American answer. No cosplay faces, just a clean biped silhouette optimized for throughput in warehouses and factories. Recent clips show Figure 03 jogging down a track, then calmly picking and placing items onto pallets, all driven by its Helix AI brain. The idea is simple but radical. Give enterprises a drop in humanoid that behaves like a new kind of temp worker, one that never calls in sick and can be reprogrammed with a sentence instead of a wrench. With backing from OpenAI, Microsoft, and Amazon Web Services, Figure is betting that a few thousand highly capable units will justify robot as a service pricing long before true home helpers arrive. But here is the part that should make you pause. This is quickly becoming a proxy war for industrial power. Humanoids are now a symbol of who will own the next generation of factories, warehouses, and public service infrastructure. On the US side, you have Tesla with Optimus and Figure with Helix-powered robots. On the Chinese side, Engine AI and Unitree are racing ahead, turning kung fu demo reels into exportable labor. Tesla treats Optimus as a strategic asset on par with its cars. Elon Musk talks about tens of thousands of units by 2026, starting inside Tesla factories themselves. If that closed loop works, where they design, deploy, and iterate entirely in-house, Tesla could evolve robots faster than competitors can even buy them. This is not just about cool clips. It is about who controls the embodied AI workforce of the 2030s. China is moving at what you could call state speed. Engine AI talks about mass-producing thousands of humanoids by late 2025 for manufacturing, education, and public service, effectively seeding a domestic market with subsidized robotic labor. Unitree sits at the cheaper, high-volume end with its G1, a smaller robot that runs, slides, and snaps into martial arts poses like a parkour student on too much espresso. Priced closer to a high-end electric car than a factory line, G1 is pitched as a developer and research platform, the Android of humanoids. National strategies are shaping all of this in the background. Washington frames advanced robotics and AI as key to reshoring supply chains, while Beijing has explicitly named intelligent robots as a pillar of future growth. In other words, the Kung Fu robot is carrying a lot of geopolitical weight on its metal shoulders. So what does this actually change for you? Start with work. Factory and warehouse tasks rarely repeat perfectly. Boxes deform, pallets tilt, humans cut across planned paths. A robot that can adapt its gait on uneven concrete, keep balance when a box shifts in its hands, and update its plan when a coworker steps in front is not a toy. It is a direct competitor to low-skill, repetitive labor. Analysts see the humanoid robotics market on track for around $6.5 billion by 2030, with some reports citing annual growth near 90%. That kind of curve does not stay confined to pilot projects. It spills into job postings, safety rules, and labor negotiations. Then there is trust. Can you trust a robot that knows kung fu and can run? On one hand, the same embodied intelligence that lets it land a spinning kick also lets it catch itself when a child bumps into it or when it steps on a cable. On the other hand, you are talking about a 40 to 80 kilogram machine with 20 to 30 moving joints, cameras, microphones, and a permanent network connection. It is a mobile sensor network walking through your factory, your mall, maybe your home. We do not yet have social rules for what it means when an embodied AI is always watching and always learning. In a minute, we will zoom out to 2030 and ask what a world full of these machines might feel like to live in. By 2030, if current trajectories hold, seeing a humanoid in a factory, A hospital lobby or a campus at night might feel as normal as seeing a forklift or a security camera today. The backflip videos will feel like the early iPhone pinch to zoom demos. Impressive, but almost quaint compared to what came next. The real story will be how quietly these robots slipped into workflows, unloading trucks on the night shift, guiding visitors in multiple languages, inspecting equipment where it is too hot or too toxic for humans. The question for you is not, will they be capable? We're already past that point. The question is, what rules, rights, and expectations do you want in place before they arrive in your town or your company? If you work in logistics, manufacturing, or even front of house service, this is not an abstract tech story. It is a timeline. Training robots in virtual worlds, giving them vision language action brains, and dropping them into real factories is happening now, not in some distant sci-fi decade. The companies that learn to collaborate with embodied AI will move faster and cheaper. The ones that ignore it may find that the job description changed underneath them. So here is what I want you to do next. Tell me in the comments what kind of job you would or would not trust a humanoid to do and why. And if you want deeper dives into specific players like Tesla Optimus, Figure 03, or Unitree G1, hit subscribe, because this story is moving faster than anyone expected, and you do not want to be the last human in the room to understand it.